Hello everyone, welcome back to our geometry lessons. Today we are going to start a new unit which is called trigonometric ratio. And the first lesson we are going to have a brief introduction of how the ratio looks like. Before we start the lesson, let's quickly review a key word here, which is right triangle. The reason is in this whole unit we actually talk about right triangle trigonometric ratio, which is all limited to a right triangle. So before we start, let's think about this right triangle. Right triangle, the reason we call this right triangle because it is a triangle with, yes, you are right, one right angle. So we can simply draw the different kind of triangle as long as we know one of the angle is right angle. So this is what we call right angle, 90 degree. We can all draw different kind right angle, right angle. And when you draw this, try your best to make it is more close to that right angle. I mean, if you have ruler, those kind of things, it's easier to draw accurate one. Some students just draw a simple like this one, label like this. It's not more, doesn't mean you label this will make it more accurate, but it's better just make sure it's really very close to the right angle when you draw this. Okay, so next thing for right triangle we're going to review is the three sides of a right triangle. As we know, three sides of the right triangle always follow a formula. So you can definitely pause here to think about what's the answer here. So relation of the three sides, I think probably you already get the answer. Yes, you are correct. Starting with P, which is Pythagorean theorem. So this one tells us, for example, if I label the two legs, the two sides of the right angle here as AB and the longest side is C, then we always follow this answer. So A squared plus B squared equals C squared. And this, we can use this relation to simply find the relation between those three sides. For example, if I label the two legs as 3, 4, and we can just put a value into this formula to find the longest side. And even more widely, you can just, as long as we know 2 out of the 3 sides, we can easily use this one to find the third side. So that's the Pythagorean theorem. So it's a very important factor of the right triangle. So whenever we talk about right triangle, this should be this first thing pop up into your head. However, so the reality is sometimes we cannot always have two sides. Sometimes we have angles, and it's more easy. In reality, it's more easy to measure the angle. We can use all different devices to measure this. So that's why trigonometry ratio come to more handy here because we can just use angle and one of the side to simply find the other two sides. So that will be the focus today, which is called trigonometric ratio. However, in order to understand the trigonometric ratio, the very first thing we need to focus on is how can we label three sides. So as you know here, a triangle has three sides, and we need to label the three sides can be very different based on the position of the angle. So and also in this unit, you will be seeing this kind of letter which is called Greek letter, theta. And sometimes we just use the Greek letter to label the angle. So one of the example here is called theta. So for example, if you put this symbol here, meaning the angle measurement here is, or we just call theta. We use, instead of using letters, we can also use theta or different kind of Greek letters to label the angle. That's something you will see in this unit. Okay, so come back to this question. How do we label the three sides here? One of the side is actually always stay like this, which is the longest side of the right triangle. The longest side of the right triangle is always called hypotenuse. So some student might say, I cannot tell if this is always the longest side. Another way to look at this is when you look at the right triangle, you draw the arrow to that side, which is, right in front of the right angle here, which is called hypotenuse. And in the future, we just label this as H, stands for hypotenuse. And then the next important thing is the reason we have this angle here, because we are going to use this angle to label the other two sides. One of the sides, which is the opposite side of this angle. Again, same as that one, I can simply draw this arrow from the angle. You can also imagine you are the person standing here and looking at side in front of you, which is BC, and this side is always called opposite side. So this side is standing in front of the angle, which is called opposite, and we use O, stands for this opposite side. And the one next to, you can imagine you are standing on this angle position, and this side is actually stand on your under your foot. It's like the ground you are standing on. And this side is called adjacent. And this, we just use A. Okay, so this is all the three sides: opposite, adjacent, and hypotenuse. O, A, and H. Hypotenuse is always the longest side, or as you mentioned, is the opposite side of the right angle. However, opposite and adjacent are not always like this. If I give you a different angle, for example, if you focus on the angle B, that will be totally different. So that's why we are going to look at these two examples here. The first one is angle. Let's label the three sides of angle A. So as you know, the longest side, of this one, we can just label this as H. And for this one, we just quickly draw the arrow. Remember, you are the one standing here looking at the side in front of you. This is opposite. And then the one next to this, adjacent. And for this one, a different example here. Again, no matter where the angle is, we can always use right angle here. Label this hypotenuse. And for this, remember, you are the one standing here looking at the side in front of you, which is opposite side. And the rest one, adjacent. Okay, so as you can see, different angle here will give us different position for opposite and adjacent. So please make sure, always remember where is the angle and how to label the three sides. The reason we need to label the three sides, because these three sides will define trigonometric ratio, which is coming from SOHCAHTOA. So you may wonder, what is SOHCAHTOA? SOHCAHTOA is just a short name to help you to remember the three ratios we are going to learn in this unit. The first one is called sine. So do not just read this as sin, which is because S-I-N. It's actually read as sine. Sine theta, as you can see, the definition for sine theta is a ratio between the opposite side and hypotenuse. So that's why we use SOH, stands for sine is equals to opposite over hypotenuse. And when we write down the ratio, we always put the name of the ratio in front and then follow the angle. So next do not read it as cos, it's cosine. Cosine theta is adjacent over hypotenuse. And as you can see here, since it's adjacent, so it's A over H. And the name of the ratio is called cosine, so that's why it's CAH. And the last one, do not call this tan, it's tangent. It's very easy to just read it as, you can see here. The full name is actually tangent. Tangent is O opposite over adjacent. As you can see, is O over A. So that's why we just simply write down as TOA to remind you this is definition. However, whenever you write down this ratio, you cannot do this. TOA equals something like that. That's wrong. This is just a way to help you to remember the formula, but remember the definition, but it's not how we name it, how we write it down. We write down the ratio of the name. For example, this is sine, and then follow the angle. Next, we just put the ratio here. Okay, So that's a definition for the trigonometry ratio. Then we are going to practice a simple one here. So we are going to have a triangle here, as you can see, ABC, and we are going to write down the trigonometry ratio based on the angle A here. And before we do that, let's quickly write down SOHCAHTOA. SOHCAHTOA is 1. We are going to write down the ratio. So the first one, S, stands for sine. But before we start, let's quickly label the 3 sides here. The longest one, H. Opposite side of angle, because we are working on angle A. So opposite side of angle A is O, and this is A. As we know here, we write down the name of the ratio and follow the angle sine A equals, we know is opposite over hypotenuse. So that's why it's opposite, which is 3. We just plug in here. And the hypotenuse is 5. So it's 3 over 5. You don't need to convert it to decimal. We can just keep a fraction like that. Next is going to be, again, this is not cos, it's cosine. Cosine, follow the angle, which is A here. And cosine, according to the definition, which is adjacent over hypotenuse. So adjacent, which is 4, and hypotenuse, which is 5, so 4 over 5. Next, T stands for tangent, which is TAN, and follow the angle A here. The definition is opposite over adjacent. In this case is opposite, which is 3, over adjacent, which is 4. See, that's a definition for trigonometry ratio. Okay, so that's it. It seems a bit long, so we focus on the very first part. How do we label the 3 sides? And then this is the definition of the ratio. Please make sure you write down these definitions in your notebook or somewhere you can easily to see, so you can memorize all these 3 formula. It's not so hard as SOHCAHTOA, but always remember what does that mean for O, for A, and for H. And that's the example here. I hope this video is helpful. We will definitely go over this lesson later. And thank you so much for watching this video. See you soon, everyone.